Hi everyone. Good evening. So please let me know whether this audio, video, everything is fine or not. We'll start immediately. Hi everyone. Hopefully everything is fine. Okay. Well, so this is our second lectures in our digital sum up series. So I hope you are doing good, and Gate 22 exam is going to happen after 1.5 months, probably, right? If we see, not even 1.5 months is left. December is almost done. So January month, so I can say around 35 days we have at max for Gate 22 exams. Hopefully, you are revising well and you are writing test and all, right? So let's start. So in the last class, we have completed the number system topic. And in the number system topics, good number of questions and the varieties we have already covered, right? And I hope you have, the session was definitely beneficial to you. And today's session will be also, something important. And again, I have selected few PET model questions, which are expected to, which is expected, we can expect the questions are going to come from these all segments. So in Boolean algebra, okay, so I have written here 6 models, namely based on Boolean expression simplification, based on finding mean terms and max terms, based on consensus theorems, based on switching diagram, based on Venn diagrams, and based on duality. So, these are what the kind of models that we can expect questions from this. Okay, so let's get started. But the intro point I would like to tell here, that is, remember, from this particular topic from Boolean algebra, the main point is the questions what you get. So those are kind of heat and trial model questions. I mean, why Boolean algebra is extensively used? As you know, the reason why we use Boolean algebra is to simplify the Boolean expression. And to simplify Boolean expressions, we have different approach, and Boolean algebra is one of the approach. Now, the main point is to simplify expression in Boolean algebra, you need experience. So there is no such roadmap like if you follow these methods and this is what the step if you follow, you'll not reach the answers that way, right? So let's get started. Okay. So again, I'd like to give you some concepts based on this, and then I'll be taking the corresponding questions. So Boolean algebra, here we have only 3 operators, namely not operator, and operator, and or operator. See this screen? So the property of AND operators I have written here. That is A dot A is A dot A bar is 0, A dot 0 is 0, A dot 1 is A. So these are the 4 property of AND operator. Similarly, OR operator properties, A OR with A is A. It's not 2A. A OR with A bar is 1. A OR with 0 is A OR with 1 is 1. So this is what, like 4 stand property of OR operators. So no matters how simple or how complicated we get the corresponding Boolean expressions, all of them can be answered using this fundamentals 4 property. Okay, so let us take and here one more thing, and most frequently, okay. So this distributive property, this is important. Very frequently we make use of this. That is, if we have A plus BC, that is equivalent to A plus B added with A plus C. So this property is used very extensively. Okay, so let's get started by solving some questions. So the first question I have taken here is, Find mean term and max term of following functions. Okay. So this is such kind of questions you can expect in GATE 22 exams. So I have given here two bits, bit 1 and bit 2. So let me know what is your answers. So you have two functions, f1 and f2. Both are three variable functions. So I'm waiting for 1 minute and let me see how many of you are able to answer these questions in a very short span of time. So directly or indirectly, one questions from these segments every year we are getting. Let it be from multiplexer concepts. Let it be from direct this kind of questions. So directly or indirectly, this kind of questions we are getting. Maithali is saying, hi sir, I was a student in 2022. I'm glad to inform you I joined IIT for my MS. Thanks for your class and guidance. Thank you. Thank you. And congratulations. IIT Madras. Okay, which stream you joined? Maithali, okay, I don't know, like 2022. So definitely online batch only, right? And after COVID, offline is not happening. So definitely we're eager live students only. So the ultimate point is, you see, every year, I know I'm training so many students. Okay, people are getting selected in PSUs, IITs. Okay, it gives some kind of happiness to me as well. So when I get this kind of success story, I feel happy. And please do keep sharing like this. So many are there who are sharing in my personal Facebook messengers and WhatsApp and all, who have my numbers and all. Otherwise, it's okay. Well, Mayank has given some response. What about other people? Okay, let us see. So we have some shortcuts. One thing that you should know, like in this mean term concepts and max term concepts. So variable you see here. In mean terms, variable is taken as 1 and variable bar is taken as 0. And in max term, it is opposite. Variable is 0 and variable bar is 1. In mean term, we go for SOP, sum of product forms. In max terms, we go for POS, product of sum. So these are the properties of mean terms and max terms. Again, it is in the handbook, but this information is quite essential to solve these problems. So what I'm doing is, for this F1, so here I can see there are three terms. One is AB, one is AC bar, and one is BC. So here C variable is missing, here B variable is missing, and here A variable is missing. So for one missing, I can write two combination 0, 1. Here also same story 0, 1. Here also same story 0, 1. So A is 1, 1, B is 1, 1, 1, 1, 0, 0s, 1, 1, and 1, 1. Why I'm getting this 1, 0, this kind of things? Because I said, so in mean term case, variable bar is 0. So in this C bar, you can see I'm writing here 0, 0s. Whereas if I get variable, let's say here B, I'm writing here 1, 1. If you see, this is 6, this is 7, this is 4, this is 6, this is 3, and this is 7. So for F1, if I ask you, the mean terms are 3, 4, 6, and 7. If these are the mean terms, if I ask you what are the max terms, so the missing index, those are nothing but the max terms. If I ask you what are those, so 0, 1, 2, and 5. So these are max terms. So for the function F1, these are the mean terms and these are the max. This is the answer. All right. Now let us go for this F2. So why I have given two questions? So there are two possibilities. The expression what you get in the GATE exam, it can be from SOP forms or it can be in the POS forms. So the first one is from in SOP forms and the second one I have given here for POS forms. So do let me know. So what is the answer for POS? What is the max term for POS and what is the mean terms for POS? So again, the same story. So you have A, you have B, and C is missing. Then you have A missing, you have B plus C bar, right? So B plus C bar. Then you have A is present, B is missing, and you have C. So again, in the max term notations, So variable is treated as what? Opposite to the mean term cases. Variable is 0, variable bar is 1. So here 0, 0, 0, 0. Because it is variable, it should be 0. And we have only one dash, so we can write two combinations. So here it is again 0, 1, right? And here it is variable means 0, variable bar means 1. So variable means 0, variable means 0, and it can have two combinations. But this is what we whatever the numbers we'll get. So those are the max terms only. Those are the max terms. 1 second. Yeah. So these numbers are 0, 1. This is 1, 5. This is 0 and 2. So these are the max terms. So if I ask you what are the max terms are 0, 1, 2, and 5. If 0, 1, 2, 5 are max terms, so the corresponding mean terms are 3, 4, 6, and 7. So this is what is the answer for F2. Okay. Hopefully all of you are getting the same answer, right? So this question is based on this finding mean terms and max terms. So we have solved questions based on this. Okay, let us go to the next questions and let's try to attempt this. This question is asked in one of the previous year engineering service objective exams. Okay, the question is if x, y, and z are Boolean variables, then the expression which is given is equals to. So basically, we have to simplify this particular expression. Okay, so please, students, who are watching this session live, if you have not subscribed, subscribe to our channel and give a thumbs up and share to your friends. Okay, if you have any queries related to this particular subject, this particular topic, or some other topic, okay, I'll be happy to help you. So even if your friends, even if they are not Gate Forum paid students, like whatever it is, okay, if they will also come, I'll be happy to share my knowledge. Okay. Anyway, we are doing this as YouTube free sessions only, right? So you can share with your friends. Okay. So tell me, what is the answer of this question? So the expression given here is x and with x plus xy, z, then x plus y plus z. Okay. So this is equals to what? This is what we need. Any answers? There are 4 options. Any answer, please? Which is the correct option? Sumya Kishore, yeah, you are right. Kusagra, you are right. Anuska, you are right. Right. Anuska responded, it is D, XZ. What about others? All of you are getting the same answer, XZ. All of you are getting the same answer, XZ. So 2 people responded. Puzan Kore also responded XZ. Okay, so 2 of you have responded XZ means it should be XZ. Let us see. So what I can say is, so this x plus xy, okay, this x plus xy. So if I take x common, this is 1 plus y, and 1 plus y is 1. So this is basically x. So this overall thing is x, and this is also x. And what is x and with x is again x, isn't it? So this is x, this is also x, this is z, and then you have x plus y plus z. But we have already seen the property a ANDed with a is a. So x ANDed with x is x. So this is xz with x plus y plus z. Isn't it? Xz with x plus y plus z. Now, if you simplify this, you get xz the first term. Second term you get it is xyz. And the third term you get is xz. Isn't it? So xz ANDed with x is xz. Xz ANDed with y is xyz. And then it is xz. If you take xz common, so you can see here xz is common from all of them. So you get 1 plus y plus 1. So this is xz into 1. So this is equivalent to xz. So of course, the option is D in this case, xz. So some of you might have solved these questions in your own approach, okay? But this is what one of the approaches. That's what I said. For Boolean algebra questions, we don't have any particular roadmap. Like if you follow these all steps, you'll get the answers. We can't say that too. So hopefully this is correct. So I hope you don't have any doubts on this. Very simple. So such kind of questions are coming in GATE exam. Okay, 1 mark questions you can expect of this kind of questions. So let's go to the next model. This question is asked in Engineering Services 2016. So selectively, I have selected these questions because, as I said, in GATE exam, skill-based questions, you need your brain to answer them. But some frequent model questions you can answer. So selectively, I have collected these all questions. Okay, so which are definitely more likely these model questions are going to appear in GATE 22 exams. Yeah, please. Again, I'm waiting for your response. I'm giving you 1 minute of time, and then I'll give the corresponding solution. The question is simplified form of Boolean expression is. Mayank, Soumya, and Anushka, Kusagra, you all people, please. Posan, you please respond it. And why other people are remaining silent? Why you are not participating? And if the attendance is more, okay, so this question which I'm solving, okay, so these are kind of regular questions I'm solving. I mean, these kind of questions are going to come in GATE 22, that is confirmed. I mean, this model of questions, I can't say that this is what the question will get, but these model of questions you will get. So, after the GATE exam, probably in the February 1st week or 2nd week, when the exam is done, immediately we'll be taking these solution sessions. So there again, I'll be referring these all sessions. You see, this is what we have discussed in our sum up series, and you see this model question has come. Okay, at least I can say more than 50% of the questions will be definitely belonging to these all models which I'm taking now. So please, you please try to participate in the discussions. Okay, don't be a statue. And if you motivate me again, I'll be motivated to conduct more and more sessions, and where I'll be also collecting the tricky questions or skill-based questions where you need your brain to answer them. Okay, fine. I mean, it doesn't mean that these questions you don't need brain. You also need brain for this as well. But those are kind of something more standard compared to these all questions. I think all of like GATE exam, all questions are not tough questions, right? All questions are not tough questions. Like every question is tough. That is a wrong concept. It never happened that way. Yeah. So some of you have given the answer. It is B. So let me see whether it is B or something else. So how do you get it? So one thing is confirmed. This is based on the De Morgan's theorems. We have to use De Morgan theorems. What can be said is, we know A plus B whole bar by De Morgan's law is A bar dot B bar. So this is what, okay? I mean, this A plus B bar, I can write this way. So that means, what is this Y if I ask you? So this is equivalent to AB plus C bar and with A bar B bar plus C. Or you can say this is C bar plus AB by commutative law, and this is C plus A bar B bar. Here one logic I'd like to give you. So this is a property you may use. Suppose I have a situation something like this, A plus B, and this is A bar plus C. Okay, so the point is the first variables are complement to each other. So here I have A and here I have A bar. So they are complement to each other. In this case, the simplified form is it is A bar B plus AC, the inner product plus outer products, A bar B plus AC. So intentionally I have written it is this way. Okay, so you can see here. So here also the first variables are complement to each other. Here I have C bar and here I have C. So this answer is product of this plus product of this. So the answer is ABC. Okay, plus it is A bar, B bar, C bar. ABC plus A bar, B bar, C bar. But it is not the final answers. You need to take the what? Complement, because in the original questions we have the complement. So I'm putting a complement here. I'm putting a complement here. Again, I'm putting a complement here. So now you can use the De Morgan's law. If you use De Morgan's law, it is A, B, C whole complements plus its dots. This is A bar, B bar, C bar whole complements. So this is A bar plus B bar plus C bar using De Morgan's law. This is A plus B plus C using De Morgan's law. So naturally, the option is B. So this question we can see is based on the Boolean expression simplifications. Hopefully, all of you are getting the same answers, B, right? So B is the right answer for this. So if you see our list, so based on Boolean expression simplifications, these two questions which you have taken, that is based on Boolean expression simplifications. So the next question I'm going to take is based on the Venn diagram. You see this fifth one, okay? So I'm going to take this question from Venn diagrams. Last year in GATE 21, in instrumentation, there is a question from Venn diagram. So Venn diagram questions are very straightforward, but of course, you should at least know the basics to answer them. Yeah, please respond this. So let me see how many for answering this. The Boolean expression for the shaded area in the given Venn diagram is, okay? So what is the expressions for this shaded part in this Boolean algebra? I mean, this in this Venn diagram, what is the expression, Boolean expression for the shaded part? Mayank is saying it is D. Let us see. Okay, so one of the simple way to handle such kind of question is, so you simply bifurcate the shaded part. So here I can say I have, if I classify them, I have basically three shaded part. One is this part, one is this part, and one is this part. If I ask you what is the expression for this, so in this part which is highlighted, A is present, B is present, C is not present. So A dot B dot C bar. A is present, B is present, C is not present. So it is A, B, C bar. So this part, if I ask you what are the expressions, so A is present, C is present, B is not present. So it is A is present, so I'm taking A. B is not present, so I'm writing B bar and then C. And the third segment, if I ask you, so here A is not present and B and C are present. So it is A bar, then it is B, and then it is C. A bar, B, C, right? And final answer is the combination of these all, the OR combination of these all. Basically, if I do OR combination of these three segments, I'll get this shaded part. So the answer is OR combination of this A, B, C bar plus A, B bar, C plus A bar, B, C. Answer is option B. Satabdi, you said answer is B, and yes, answer is B. You are right. So this question is based on Venn diagram. So now this question I have taken from switching diagram concepts. Okay, switching diagram questions. Okay, also in previous year GATE papers, there are some questions from the switching diagram as well. Let's see what is the answer of this. Again, I'm giving you 1 minute of time. Okay, you please try to answer this. The question is, the minimum Boolean for following circuit is. So basically, we have to get again the Boolean expression which is representing this switching diagram. So what is the concept you need here? So whenever these switches are in parallel, okay, so you have to do OR. When the switches are in series, you have to do AND. Okay. So how do you answer this? For this particular segments, okay, for this particular segments, so switches are in parallel. So this is representing B plus C bar. And this is in series with A. So if this segment, if you consider, so here we should AND with A. Then here we have two switches in series. So the expression corresponds to the series combination is A bar with B. And what is the expression corresponds to this? I mean the third segments. So corresponds to third segment. If you see, it is again A plus B bar and with C. And finally, all of them should be odd because equivalent, if you see, all these three pass in parallel. So parallel means or and series means and. So if I represent this by Y, okay, if I represent this by Y, so what I can say is Y is equals to AB plus AC bar plus A bar B plus AC plus B bar C. This is what you're getting, right? So you may simplify this and you can get the corresponding answer. So from this and this, if I take A common, I'll get A only. C plus C bar will be 1. So from A, so I can say here AC plus AC bar is equals to A if I take common. So C plus C bar is what? So it is A. So this is A plus AB plus A bar B plus B bar C. But what is A plus AB? So A plus AB is equals to A. Isn't it? A plus AB, if you take A common, it is 1 plus B. 1 plus B is 1, so this is A. So here I'm writing A plus A bar B plus B bar C. But what is A plus A bar B? A plus A bar B is nothing but A plus A bar added with A plus B bar C. So this is A plus B added with B bar C. So this is A B bar C. Answer is D. A plus B plus C. Any mistake is happening? Yes, A plus A bar, A plus B bar C. Here I have a plus sign, isn't it? So if it is plus sign, 1 second, sorry. So this is equivalent to A plus. So this I can say it is B plus B bar and with B plus C. So this is equivalent to A plus B plus C. So of course, if it is A plus B plus C, that is option D. So if you see this, so we are done with this switching diagrams and we are done with this Venn diagrams. Okay, so let's see what is the next questions after this. So this question is based on duality. Okay, so please try to answer this. Let me know what is your answer. So what is the dual of these expressions? For your information, so why we need dual? So dual is used to get the negative logic equivalent expression of positive logic or vice versa. In other words, if you have the expression, it is in positive logic system. If you want to know what is the equivalent expression in its corresponding negative logic system or vice versa, you need concept of duality. And how to get the dual of the functions? The and should be replaced by or should be replaced by and. So the simple logic is you have to replace the dot with plus. I mean, you have to interchange the dot with plus. So dot should replace by plus and plus replaced by dots. If you do it, so what do you get in this case? So very simple. So here A, I'm writing here A plus A replaced by dots. Again, parenthesis should be there as it is. This is B. This plus is replaced by dots. Then here AC. AC, I can write this is A plus C because dots should be replaced by plus. Then you have plus. So plus is replaced by dots. And then this is D. So I can say it is A added with B plus A plus C with D. So which is given in option C. A plus, no. It is not C. 1 second. What is it? Yeah, it is D. It is D. It is D. D is the right answer. Isn't it? And the last question I have taken from this segment is, which is based on the consensus theorems. So nobody will tell you like solve these questions using consensus theorem, not that way. Okay. So if you know these theorems, so some time we can save. So what is this theorem is? So the theorem is something like this. So I have written the theorem here first. So let us understand the theorems in brief, and then we'll solve this particular questions. So the question is obtain the minimized expression of this particular expression. Okay, what is the minimized version of this? So what the consensus theorem says? So you see the first one is AB plus A bar C plus BC. So what thing you have to understand in this case is, so you notice one thing, a variable and its complement will be present in the expression. In other words, if I see there are three variables A, B, C, so A and A bar are present. So a variable and its complement will be present in the expressions. Then you see what is the associated terms with A and A bar. So the associated term with A is B, and the associated term with A bar is C. If the third term is and combination of associated terms, I mean BC, then this is a redundant terms. So this expression will be equivalent to AB plus A bar C. This is I'm explaining with respect to soft forms. Same is the story applicable for pause as well, which is this expression. Again, I'm repeating. So one variable is present in both normal and complement forms, and you simply see what is the terms associated with them, and if the third term is and combination of these associated variables, so that can be ignored. Okay, so this is what the answers. So please tell me what is the expression of this questions. So it is AB plus A bar CD plus BCD. So what is the minimized expression of this? Of course, there are multiple ways to answer this, but what it will be. So, in the exams, it will not be given to you like you answer this question in the consensus theorems. So by observing the pattern, the ideas will strike to your mind. I'm not saying that if you don't know consensus theorems, there is no alternate way to answer this. Not that way. But if you know consensus theorems, you can save some time. Mayank has responded, it is AB plus A bar CD. Okay, is it correct? Let's see. So here, if I check, I have the A present and A bar present, right? So again, the same story. So associated variable with A is B and associated variable with A bar is CD. Then I should check whether the third term is AND combination of the associated terms. Associated terms are B and CD. Whether is it the AND combination of B and CD? Yes, it is AND combination of B and CD. So in this kind of cases, this can be ignored, right? So the equivalent answer is AB plus A bar CD. AB plus A bar CD. Okay, this is what is the answers. Anyway, I have not given options in this case, but if it is a MCQ questions, you will get one of these options. Okay, so this is what all about your Boolean algebra, particularly fun Boolean algebra, concepts. So you don't get any questions beyond these models. Hopefully everything is fine. You want to share your inputs? You have any doubts? You have any queries? You want to ask something more? Please let me know. Please write in the chat box. We'll discuss it. Okay. And with this, Boolean algebra is done, and we are switching to the next particular topic. That is nothing but the logic gates. So again, in logic gates, I have here how many varieties? 6 variety actually, right? So we'll see them one by one. So logic gates, if you see in a broader sense, in logic gates, majority of the questions in logic gates are targeted from the XOR XNOR cases. So property of XOR and XNOR are very, very important. Okay, very, very important property of XOR and XNOR. Okay, so let me quickly highlight them and we'll take up the questions. Like A XOR 0 is A XOR 1 is A bar. If A is XOR n times, answer is 0 if n is even. Answer is A if it is n is odd. And these property are very, very important, right? If you know these all property, so the students who have listened my live lectures, you might have seen how many questions we have answered using these beautiful properties. In fact, in today's session also, some questions I have taken which will be answered using these all properties. So actually, if I say what is A XOR B, okay, so it is given by A bar B plus AB bar, right? This is the expressions. But always, expanding the XOR operator this way will kill a lot of times. So knowing the property is quite essential. Okay. So you see here, AB XOR with BC is B ANDed with A XOR C. It is like you can take the B common. Next property is A XOR with B XOR with AB is A plus B. A XOR with A bar B is A plus B. Okay. And A bar B XOR with A B bar is A XOR B. Okay. So, and coming to XOR cases, so A XOR B is A bar B bar plus AB. Okay. And in this case, these are the corresponding properties. A XOR with 1 is A XOR with A is 1. A XOR with 0 is A bar, A XOR with A bar is 0. And if you see this bunch of properties, okay, so what can be concluded here? So A XOR with B bar is A XOR B, A bar XOR with B is A XOR B, A bar XOR with B bar is A XOR B. Okay, so what is the point here? If one of the variable is complemented, then XOR operator become XNOR operator, right? If I'm complementing one of the variable, like B is complemented, you see XOR is become XNOR. But if both variables are complemented, XOR remains as XOR. So here A is complemented, B is complemented. So here it is again the XOR operator we have. And this XOR operator, it follows some kind of De Morgan's law. That is, if I ask you A XOR B XOR C XOR D complements, so it is simply you complement every variable and replace the plus with dots. So if you do that, this is equivalent to A bar XOR with B bar, XOR with C, XOR with G bar. Okay, so same is the story for this expression as well. So you can go through it. Okay, so good number of questions are asked in the past year papers, and in the upcoming GATE 22 exam also, you are going to get questions from XOR gates. Okay, so I can tell you one thing. In the GATE exam, if there are questions from logic gates, 99% of chance the questions will be related to property of XOR gates or based on the delay. So basically, this one, the third category, based on delay, this one, and based on property of XOR and XNOR. 90% of the questions in GATE exams, it has happened in the past history, and it will again repeated in the GATE 22 exam also. If there is a question from logic gates, most likely the question is from these two categories. Okay, so let us see. So the various category we have is based on finding output of the circuits. Okay, so this is a question which is asked in Engineering Services 2010. So a circuit is given to us here. So the Boolean expression for the output of the below circuit is. So please respond. What is the answer? I'm giving you 30-40 seconds of time, and then I'll solve this. Yes, any answer? So such kind of questions are coming. So some circuitry will be given where some combination of gates they would have used, and you'll be asked to find what is the output expression of this particular logic circuits. Okay, nobody responded. So this is nothing but your A XNOR B, and this is your C. And what is this Y? So this is a NAND gate, right? So this is A XNOR with B. Okay, so this is NANDed with C. So this is equivalent to, if I use De Morgan's law, okay, what can be said? So this is equivalent to A XOR B whole. Okay, so so we can do this way. 1 second. You can write this way. So this is A XOR B whole complements plus this is C bar, isn't it? So what is A XOR B complement? It is A XOR B, and this is C bar. What is A XOR B? A XOR B is, of course, it is A bar B plus A B bar plus C bar, right? A bar B plus A B bar plus C bar. So which option is correct? A XOR B plus C bar, right? Anyway, okay, so this is not there in the options. So this is there in the options. So if this is there in the options, answer is, of course, it is C. C is the right answer. C. C is the right answer. So similarly, this is also a question which is somewhat similar to that model. So here the question is, consider the following gate network. Which one of the following gate is redundant? This is again a question asked in GATE 2011. So what is the answer? Let me know. Let me see how many of you are able to answer this. I'm again giving you 20-30 seconds of time. Why you haven't liked the session? Please give a thumbs up to the please give a thumbs up, and if you haven't subscribed, please subscribe the channel. Yeah. So how many of you have started writing the test series? Or what is the things going on now? Is it like let go model? I mean, jo ho raha hai hone do. We'll see. Is it that way? And this is the period actually where many of students, they think like, okay, this year my preparation is not up to the marks, so next year I'll prepare. And if you are in this mentality, that next year never comes practically. Okay, that next year usually never comes. Okay, so please, if you are thinking that way, don't think. Of course, if you have less time, if you have more number of subjects to cover, so it is wise to be selective, but don't be like in a give up model. So don't be in give up mentality. Don't think that next year I'll try. That's very bad. So revision and test series. This is what should go on in this entire January month. Okay. So let's see what is the answer. So many of you are saying answer is B, gate 2. Let's see. 2 is redundant. Even if I'm removing this gate 2 from the circuits, the output expression is not going to change. So whether this gate number 2 is there or it is not there, the expression of F is C. So the answer is gate number 2. So such kind of questions you can expect in gate exam. Okay. So where you have to check which is the redundant gate. So this is also one such questions from logic gates. Okay. The question is, the circuit shown below is to be used to implement the function z, which is a bar plus b. So the question is, what is the value of I and j? Okay. So again, I am giving you 20-30 seconds. Let me know what is your answer. So it's a OR gate, right? So the input to the OR gate is A and I. So this is your A plus I. This is your A bar. And this is your J plus A bar. And what is Z if I ask you? So Z is an combination of A plus I with J plus A bar. But what do you need? We need it is A bar plus B. We need it is A bar plus B. So what we should do then? You please check the options, which option will satisfy this requirements. So you need A bar plus B. So what if I go with option B? If I go with option B, so if I take I equals to 1, so this term will be 1. And if I take J equals to B, so this is B plus A bar, or which is equivalent to A bar plus B. So answer is option B in this case. If you check all options, only this option will satisfy this requirement. So the answer is B for this. And here is the questions which is based on the property of XOR and XNOR gate. Okay. So I have 3 bits. Please respond one by one. क्या हो रहा है? हाँ? So if you see this, we are done with based on finding output of the circuits. This is what we have completed now. So the questions which I have taken that belongs to this particular model. So now this question which I'm going to take, so this is based on the property of XOR and XNOR. So if you remember, we have seen a property here, that is this property. A XOR with B XOR with AB is equals to A plus B. Is that no? So keeping this in mind, so if I ask you for this one, so the first bracket term is equivalent to A plus B. In the same way, the second bracket term is equivalent to A plus C. So first bracket term is A plus B, second bracket term is A plus C. And what is A plus B with A plus C? So this is basically A plus BC. So the answer for the first question is A plus BC. How many of you are getting this? A plus BC. I haven't given any option for this, but you should tell. Kusagra is getting the same answer, A plus BC. Good. So what is the this second bit answer? So what is the answer of the second bit? So this I can write this way. If I interchange these two position, so this will be A XOR with A, XOR with B bar. So I'm putting a bracket here. And then it is XOR with B. I'm again putting a bracket. I'm just interchanging these two because XOR, XOR both get they satisfy the commutative law. So A XOR with A, XOR with B bar, XOR with B. Then XOR with 0, XOR with 1. Okay. XOR with A bar, XOR with B. So what is A XOR A? 0. And XOR with what is B bar XOR with B is 1. Again, XOR with 0 XOR 1 is 1. And XOR with what is A bar XOR B? A bar XOR B is nothing but A XOR B. So based on the property. So if you see, so this is 0. XOR with what is 1 XOR 1 is 1. XOR with A XOR with B. So what is 0 XOR with 1? So 0 XOR with 1 is 0. So 0 XOR with A XOR B. So what is 0 XOR with A XOR B? It is A XOR B for complement. Why is that? Because A XOR with 0 is A bar. So 0 XOR, this is complement of A XOR B. So complement of A XOR B means it is A XOR B. And what is A XOR B? It is A bar B plus AB bar. A bar B plus AB bar. So this is the answers. So if somebody asks you what is the simplified version of this, so you can say it is simply A XOR B. Yeah. So this is what is the second bit. And what is this third bit? What is this third bit? Please respond for this third bit. What is the answer? So what is the answer in the sense, what I can do is, So from the first three terms, I can take B common. If I take B common, so this is 1 XOR with A, XOR with AC. Is that fine? And this is XOR with 0. And what is this 1 XOR with A? 1 XOR with A is A bar. So this is A bar XOR with AC, and this is XOR with 0. And what is A bar XOR with AC? What is it? If you know property, Sandipan Bhaumik, sir, can you repeat this problem? Which problem? Okay, let me finish this and we'll come back to that. So this is B with, what is this A bar XOR with AC? So what is the property of A XOR B? A bar B plus AB bar, isn't it? So it is A bar A dot with AC whole complement. A bar B, A bar B plus AB bar, that is A bar with AC whole complements. This is XOR with 0. So this is equivalent to B with, this is AC only, plus, what is this AC whole bar? Is A bar plus C bar. So it is A bar plus A bar C bar, and XOR with 0. Is that fine? Because this is equivalent to AC, and by De Morgan's law, you can write this is A bar plus C bar. So this is equivalent to A bar plus A bar C bar. So B, and from this last two term, I can take A bar common. So it is A bar. Okay, and XOR is 0. So this is B, and what is A bar plus AC? Is A bar plus C. So this is A bar plus C, XOR with 0. So this is A bar B plus BC, XOR with 0. And because we know A XOR with 0 is equals to A bar, so this is equivalent to A bar B plus BC whole complements. So this is equivalent to A bar B whole complements added with BC bar BC whole complements. And if you need further simplifications, okay, so this will be equivalent to by De Morgan's law, it is A plus B bar added with B bar plus C bar. So it is AB bar. So anyway, here the first terms are same, right? We can say it is B bar. So this is equivalent to B bar plus A with B bar plus C bar. The first terms are same. Answer is B bar plus AC. B bar plus AC. This is what is the answers. Bit lengthy, but logically if you go, this is what the answer is. Again, let me repeat. So in the first step, I have taken B common. If I take B common, so you get 1 XOR with A, XOR with AC. So 1 XOR with A is A bar, and this is AC. So A bar XOR AC is A bar B. So A bar is A and B is AC plus AB bar. So A bar added with complement of AC. So complement of AC is equivalent to A bar plus C bar. So this is equivalent to B added with AC plus A bar plus A bar C bar. So A bar plus A bar C bar is A bar. So it is equivalent to AC plus A bar. So which is A bar plus A with A bar plus C. So it is equivalent to A bar plus C. XOR with 0. So this is A bar B plus BC XOR with 0. So it is equivalent to whole complement of this, because A XOR 0 is A bar. So if you take complement of it, A bar B plus BC whole complement. So this is coming as A plus B bar added with B bar plus C bar. And if you simplify this, it is coming B bar plus AC bar. So hopefully all of you are getting the same answers. So sometime the questions will be this way, okay? I mean, where you have to deal with the calculation part as well. So hopefully this is fine. Somebody was asking, Sandeepan, you were asking, can we repeat this problem? I think you are asking about this second problem, right? This one. Where is the problem here? So first step, I have just interchanged the position of this B bar and A. And then intentionally, I have put it here brackets to deal with two variables. Then I have followed the standard property. A XOR A is 0, we know. B bar XOR with B is 1, we know. Okay. So A XOR A is 0. XOR with B bar XOR B is 1. XOR with 0 XOR 1 is 1. XOR with A bar XOR with B is A XOR B. So this is the property in that list in handbook I have already shown you. So this is 0 XOR with what is 1 XOR 1 is 1 and XOR with A XOR B. So 0 XOR with 1 is 0, XOR with A XOR B. So 0 XOR with A XOR B is A XOR B whole complement, which is A XOR B, which is A bar B plus AB bar. So such kind of question you may expect. So this I am saying the questions based on the XOR and XNOR. Okay. So next question I'm going to take based on union and intersection concept. Okay. So this model questions is not very frequent like the other ones, but yes, there are chances you may get question from this. So this question is asked in Civil Service Examination 2006. Consider the logic function shown in the figure given below. The function f1, f2, and f in canonical sub in decimal notation are given, right? So the mean terms of f1, mean terms of f2, and mean terms of f is given. So which of the following is the function of f3? So we need to find this f3. So here the concept that somebody need is the dot operator or the AND operator. So this is equivalent to intersection operator. So this is the standard property. Similarly, the plus operator or operator, this is equivalent to a union operator. So that means if you are dealing with some functions and you know their mean terms of these functions, then you can use this intersection and union to deal with them. So in this case, what I can say is f1 and f2. So it's an AND gate, right? So this is your f1 and this is your f2. So what is the mean terms of output of the AND gate means? That is nothing but the intersection of these mean terms. So what are the mean terms common? So I think 8, 9, 10, and here I have only 8. So 8 is common. So it means, so the mean terms of output of this is only 8. And f having mean terms is known to us is 8, 9, right? If this is 8 and you are getting a 9, that it's an OR gate. So OR gate will produce union of the inputs. So 8 is coming from this way, and F3 should definitely give mean term 9. So if F3 will give mean term 9, the output will be union of 8 and 9, which is 8, 9. So in this case, definitely the answer is B. Straightforward. Okay. So hopefully this is fine. And the next question I would like to take is based on the universal logic circuits. Okay. So from this also, there are questions in the GATE exam, and it is expected you may get again questions from this area. Well, so I don't know whether it is visible or not. Yeah, now it's okay. So this question is asked in civil service conventional paper. The question is, minimize the soft terms given in a Boolean function. Implement the minimize function using NAND gates alone. So of course, in the GATE exam, they will not ask you to draw the circuits. So the same question they can ask you, okay, minimum how many 2-input NAND gates are necessary to implement this function? So such kind of question they may ask. And we are getting questions this model very frequently. So let us try to answer it. Okay. So what is the approach? So you have a function f whose mean terms are given, and you have to design the corresponding circuits using NAND gates. So how do you answer this? So I'm using the concept of K-map in this case. Okay, Moin-Croisert K-map, yeah. Because if I use K-map, I'll get the expressions, and once I see the expression, then I can think what I should do. So it's a 4 variable cases. If it is a 4 variable cases, so I'm taking the 4 variable map. There are 16 cells. Okay. This is for AB and this is for CD. So A bar, B bar, A bar, B, A, B. This is A, B bar. Similarly, C bar, D bar, C bar, D, C, D, and this is C, D bar. And the mean terms are 0, 1, 3, 2, okay, 4, 5, 7, 6, 8, 9, 11, and 10, then 12, 13, 15, and 14. How many mean terms are there? 4, 4, 8. So how many I plotted? 6, 7. Okay, one more is missing. Which is missing? 10 is missing. Yeah. So this is what the corresponding K-map, isn't it? So let us first get what is the minimized expression of F. So let us try to make the groupings. Group of 8 is not possible. If group of 8 is not possible, I should try to what? I should go for the quad. So we can see this is one quad possible. Yes. And to cover this 2 ones, so I'll be going with this quad. And to cover these 2, I'll be going with this quad. So ultimately 3 quads are enough to cover off all the groups. So for this, what is the expression? From row, you'll get A, and from column, you'll get D bar, because from row A is constant and from column D bar is constant. So A, D bar you get. Similarly, from this, from row, the first row and the last row. So the common factor is B bar. And the column, in the last 2 column, the common factor is C. So you get B bar C. And this one, okay? So from this one, from row, you get it is A. And from column, you get this is C. So F is equivalent to, what is F is equivalent to? AC plus AD bar plus B bar C. Yeah. Hopefully all of you are getting the same answer. This is what we need. But the question is, implement this alone using NAND gates. So NAND gate means we don't have scope to use this plus. So I'm putting here 2 times complements. If I put here 2 times complements, so the first complement I'm keeping as it is. So the second one, if I'm breaking, this is equivalent to AC whole complements, dot with AD bar whole complements, dot with B bar C whole complements. This is what is the answer, isn't it? So ultimately, how many gates you need? So I can say here, so you need here D bar and B bar. So one thing you need is, you need A, you need C. So this will give you AC whole complements, all right? Then you need A, D bar. So you need A, and for D bar, I'm using a NAND gate again by sorting both of the inputs. So this is your A and this is your D. So this will give me A, D bar, whole bar. Similarly, you need B bar C. So you need one NAND gate to generate B bar and C. So this is B and C. Okay. And then you need to have NAND of these. So you will get like this. So how many NAND gates we need here in this case? 1, 2, 3, 4, 5, and 6. So answer is we need 6 NAND gates. If it is a gate question, they'll ask you to implement this function using 2 input NAND gates, how many gates are needed? The answer is 6. So what we did in this case, first we have used the K-map. We have got the corresponding minimized expressions. And then you have used De Morgan's law. And then we got this in the NAND model. And if I'm drawing the circuits for verification purpose, we're getting the answer is 6. Okay, so this question which I have discussed now, so that belongs to based on universal logic gates. Okay, based on universal logic gates. And there is a concept which is called ring oscillators. Okay, so this questions I can say, more chances to come in gate 22 because from last 5-6 years, no question has been asked from this segment. Okay, ring oscillator. It's a simple formula. So what is the case is, if you have odd number of NOT gate connected in a loop, it works like a ring oscillator. So the output, if you check at any point, so whether it is this point or it is this point or this point, any point in the circuits, the output is always square wave. But the condition is there should be odd number of inverters. It should not be even number of inverters. So the output is a square wave, and the frequency of the square wave is given by 1 by 2n TPD. So where n is number of NOT gates. N is number of NOT gates. And what is TPD? TPD is the propagation delay of NOT gates. I have assumed that all the gates have same propagation delay. With that assumption, the formula is 1 by 2n TPD. So they'll be giving you, if there are 5 number of NOT gates are current in a loop, and delay of each NOT gate is 10 nanosecond. So what is the frequency of the square wave generated? So you have to make use of this formula. Okay. So I just wanted to give you this one. So hopefully it is fine. And if you see the list, I said the most important concept in this entire topic is based on delay and XOR XNOR property. So based on XOR XNOR, we have solved 3 questions. And now I'm going to take the last question, which is based on delay. And based on ring oscillator, the corresponding formula 1 by 20 we have seen. So let's see the last question for today, which is based on this delay. Okay. So this is, I'm giving you a 5-star. If a single question is asked from logic gate topics, the question is most likely to be from X or XN property or from the delay property. I mean, based on delay concepts. Are you following or not? Or is it like one way? Why all people are not participating? I'm in a flow only. Okay. You should support. You should respond. Whenever I'm asking, you have to give answer. Are you following or not? So the question is, if delay of XOR, NOR, AND gates are 1 nanosecond, 2 nanoseconds, 3 nanoseconds respectively, then draw the waveform F. So such kind of question, if you see the past papers, 3-4 times in the last 5 years, they have asked in various streams. Okay. So most likely, again, one more questions we may get. So what is the approach to solve such kind of questions? The approach is, first you assume the gate is ideal, having 0 delay, and then you introduce the corresponding delay by shifting the waveforms. So one thing I have missed in this case, actually, that the waveform of A and B. Okay. So this question actually I have taken from this handbook. So let me explain you here itself. I have the question solution ready here. Okay. So here I have this waveform A and the waveform B. Okay. I have the waveform A and waveform B. So this XOR gate having delay 1 nanoseconds and the NOT gate having delay 2 nanoseconds and the AND gate having delay 3 nanoseconds. So based on this, I am asked to find what is the waveform F in this case. So the first thing is, okay, so first in this case, I have obtained what is this A XOR B ideal. See here. So the waveform A and B are known to me, right? This is waveform A and this is waveform B. So here I'm first finding what is A XOR B ideal. So if you do XOR of the waveform A and B, so you can see between 0 to 1, 0 XOR 0. So this is 0 and this is 0. 0 XOR 0 is 0. Between 1 to 2, so between 1 to 2, so this is 0 and this is 1, right? Between 1 to 2, 0 XOR 1 is 1. So between 1 to 2, you are getting it is 1. Between 2 to 3, this is 1 and this is also 1. So 1 XOR 1 is 0. Between 3 to 4, this is 1 and this is 4, this is 0. So 1 XOR 0 is 1. So this is what is your A XOR B ideal. This is what your A XOR B ideal. Okay. So, but ideal in the sense we haven't assumed the delay of this. So to get A XOR B actual, So this waveform has to be shifted by 1 nanosecond because the delay of this is 1 nanosecond. So if you shift this waveform by 1 nanosecond, so you are going to get this waveform. So you see here the waveform which is starting at 1, it is starting at 2 in this case. So this is your A XOR B actual. Okay, so this is A waveform, B waveform, and this is the waveform of C actually. Okay. So similarly, first I'm getting what is C bar ideal, because this is nothing but your C bar. So if you find the inversion of this, so between 0 to 2 it is 1. So between 0 to 2 it is 0. Between 2 to 5 it is 0. So between 2 to 5 this is 1. Beyond 5 it is 1, and beyond 5 it is 0. So C bar ideal is, this is what the waveform. And what is C bar actual? So this waveform has to be delayed by how much time? By 2 nanoseconds. If you delay this waveform by 2 nanoseconds, okay, so you see, so what do you get? So you are going to get, this is from where? 4 to 7. It is not 3 actually, it is actually 4. So this is your C bar actual. So finally, you got this actual and you got this actual. So you have to do AND of this. So if you, which waveforms? You have to do AND of this waveform and this waveform. If you do AND of this, you can see between 4 to 5, you have the common segment, which is 1. Between 4 to 5, this is 1, and this is also 1. So you're getting it is F ideal. And to get F actual, again, you have to consider the delay of this one. So the 3 nanosecond, if you shift this waveform by 3 nanosecond, so this will cover from 7 to 8. So they may ask the questions, if these all waveforms are applied to this ABC terminal, then for how much interval the output will be 1? So directly or indirectly, such kind of question they may ask. So this is what is the kind of questions you can expect, which is based on the delay. Okay. So this is what the question based on delay. So there are 6 model of questions, and all of 6 we are done with it. So that's what for today. In the next sessions, again with some more questions and some more new chapters, we'll again continue the sessions. So how was the session today? And I hope it is definitely adding value to your preparation. As I said, if you haven't subscribed, please subscribe to the channel and give a thumbs up. And the friends who of you are right, so they're preparing for GATE, please do let them know so that they can also participate. So if they have any doubts and all, we can make these discussions more interesting. Okay. Thank you. I'm closing the session here today. Thank you.